Hello everyone, welcome to this lecture of computer system security. Today we are going to continue our discussion on token-based authentication, and we wanted to uh, actually review the last example of tokens that are used for authentication purposes, and that was the electronic identity cards. So we're going to talk about EID cards and how they're being used for authentication. If you remember, I mentioned that EID cards or electronic identity cards are in fact nothing but smart cards, which are being used for authentication. But the basic difference between these type of a smart card that you see one example here with regular or normal smart card is that they're mainly used by government and kind of official agencies in order to do authentication. So we define an EID card as a smart card that has been verified by national government and valid uh, as a valid and authentic as a way to kind of authentic individuals and citizens. For example, driver license cards might be seen as a EID card, and there other kind of physical properties of the card are mostly similar to smart cards. You have a chip, you have some uh, kind of information embedded on the chip on the card, and the card may communicate with the authentication server in order to get the authentication done and stuff like that. Yeah, and they're, like I said, basically issued and will be used by the government agencies in order to conduct the authentication process. Okay, one example of an authentication card or EID card is the EID card issued by the German country, German kind of state, and it's a mix of human and machine readable data. So this is a picture of that card you see here. Of course, there are some information here on the card that can be read by human, which are good. For example, name, date of birth, and stuff like that, address, and picture of the card holder. These are all piece of information that can be read by a human. The same kind of copy or clone of information also is embedded on the chip on the card on the smart card that can be read by a machine. So, but there are also, of course, some kind of specific information. For example, we have document number. I'm talking about this specific EID card issued by German country, and they have a document number, which is an alpha numeral 9-character unique identification number for each card, and then they have card access number, which is also referred to as CAN. This is a 6-digit decimal random number printed on the face of the card. Sometimes this we will see in the functions that we define for these EID cards. Sometimes it is used as a password for some applications. And also we have machine readable zone, which is a portion of text. It is a 3 lines of human and machine readable text on the back of the card. This part also might be, depending on some application, might be used as a password. So here are the functions which are defined for this EID card, for this specific EID card that we are talking about. 3 basic functionality are defined for it. The first is called ePass, which means that the card is being used in order to uh, kind of give the holder or give the card holder the permission to pass from somewhere. This is an offline process at which the card holder kind of shows the card, and the card is being kind of like you see here, the card holder present the card for a particular service. For example, like a passport check. You want to check your passport at the airport checkpoint control. You just show your EID card, and that serves that kind of shows all of your information that the official person needs to see, needs to kind of assess, and that's it. So that this is the ePass functionality, which is the basic functionality defined for this type of cards. And like I said, it's for authorizing offline inspections, and some piece of information like CAN or MRZ that I just explained at a previous slide might be here used as a password if required. Another functionality which is a little bit more advanced than ePass is called EID authentication. And as the card stores an identity record, that can be used, that piece of information, which can be CAN or MRZ, or in particular the PIN, they can be used to authorize some specific services to the cardholder. So this is basically used by government and commercial applications. And of course, this is an optional service. You have an EID card. You decide, you as a card holder, you decide if you want to turn this option on or not. And if you decide to turn it on or use that, you can use the EID card for kind of getting authorized to access some services that might be governmental services, or in some cases, some commercial services which are being offered by some non-governmental corporations or agencies. And the third functionality, which is defined for EID card, is called e-sign, e-signature. In this specific functionality, the card stores a private key and a certificate that verifies the key. So on the card, of course, on the electronic part of the card, not printed version, you have a key plus a certification. The certification kind of guarantees that the key is a valid key, and the key plus the certification can be used in order to generate digital signatures. So you can sign something with your card. For example, you swipe your card somewhere, and that means that you have signed that contract or that kind of agreement. Of course, like I said, a private sector should be involved in order to issue that certificate. We've talked about e-signatures and that they need to have a kind of certificate for that and the private key. So, but having that said, the PIN here can be used as a key, or there might be a separate key, and you can e-sign something, like I said, with your card. And of course, this is again something optional, not available on all cards, or not activated on all cards. The card holder decides if he or she wants to activate this service. But of course, it's very convenient and easy. You want to sign somewhere, you just swipe your card. But at the same time, it's also um, to some level might kind of bring some sort of insecurity, because if someone steals my card, they can e-sign on behalf of me. So for that, the PIN will be asked. So this is the topic of the next slide. Let me just jump here. The reason that we need to have password in EID card, because if someone steals the card, they cannot use it, for example, for authentication, or they cannot use it for uh, let's say e-signature. So for preventing or for ensuring that contactless RF chip cannot be used for unlegit e-sign or authentication, we see that there is also PIN. So the role of the PIN is very important here. So for these two last functionalities, for e-sign number 2 and for EID number 1, on top of having the card in hand, you also need to know the e-PIN. You also need to know the PIN. The card holder knows the PIN and says the PIN, and the PIN will be entered by the user who wants to use the card for e-signature or something, and that way it will be matched with the pin reserved on the card or burned into the card. And that way we can make sure that even if someone uh, steals the card, they cannot use it for authentication or for electronic signature. So that's why we say that the card also has uh, a pin as well. Okay, this slide here shows the authentication using EID. So the second functionality, these are the details of the or steps that happen for authentication using an EID card. The first step is that the user requests the service. The user wants to access to some web server or some services, which might not be even directly connected to internet, but you ask for those services. So the request goes to the application, host application, or the server. And the server, since you have swiped your card or whatever, redirect you because you have used your EID card. The server redirect you to an EID server because the application server does not have access to those to that information in order to authenticate you. So it redirects you to an EID server. The, so the authentication request will be redirected at the step 4 to an EID server, and the EID server asks for the PIN. So you swipe your card, okay, but this is the second functionality, and it is not ePass. So you are asked, the user is asked to enter the PIN. The user enters PIN, and the PIN goes to the EID server, and the authentication protocol exchange will happen. There might be some kind of multiple steps here, or not. No, just asking for the PIN and that's it. And then the server performs the authentication protocol, conducts the authentication protocol. Once the server finishes the authentication, the result of the authentication will be redirected to the host application, which is here. Will be redirected to the host application. And now the host application, based on the results, uh, the user forwards the result of the authentication to the host application, and now the host application start granting the service, whatever that service is. So this is how EID cards can be used for authentication, which is here in this slide, functionality number 2. In this slide, functionality number 2, I've just talked about this. And I also talked about e-signature. So, okay, we've also talked about the reason that we need the PIN, because for online application, we want to make sure that just having access to the card doesn't kind of make it possible for someone who may steal the card or something. Okay, the next, we are done with the token-based authentication. We've talked about the details of token-based authentication, and we've seen 3 different examples of token-based authentications. And now I'm going to, as the last part of this lecture, I'm going to talk about authentication based on biometric parameters. First of all, let's define it. What's authentication, biometric authentication? What is that? And the attempts to authenticate an individual based on some unique physical or biometric characteristics or features. This is called biometric authentication. For example, I look at the, let's say, iris pattern of your eye, and I can decide based on that, are you the person you claim or not? That's biometric authentication. Parameters or features or characteristics that they relate to our body. And of course, when I say that, it is kind of understandable easily for you that biometric authentication needs some type of pattern recognition, because my iris or my retina or my handwriting, these are all, of course, these are all related to um, features that they kind of include features that they relate to my body, or the way I write, or the way that I speak, or whatever. But they're all patterns. Of course, when I say something, for example, another example of biometric authentication is the systems that they work based on the voice. They ask you to say something, and they look at the pitches or frequencies of your voice, and based on that, they decide if you're authentic or not. But of course, if I say even a single word twice or three times, they can be different. Of course, I cannot say all the time exactly the same way with the same numbers, with the same amplitude, with the same, excuse me, with the same amplitude. I cannot repeat it with the same, let's say, power, and the ambient noise might be different. So when we say authentication based on biometric features or characteristics or parameters, it means that we have to do some type of pattern recognition. And based on that pattern recognition, uh, biometric authentication becomes by nature more complex and more expensive than, for example, password-based authentication or token-based authentication. In a password-based authentication, we are talking about a piece of information which can be stored as a hexadecimal or binary, and it's not that big, and there is no pattern there. You enter the password either matches or doesn't match. That's it. So you get authenticated, you get grant for that service, or you will be rejected. That's it. There is no pattern recognition. But when it comes to biometric authentication, like I said, we should do some type of pattern. So let's just quickly list the physical characteristics or biometric characteristics that we can use for biometric authentication. Basically, we can use two types of biometric features or characteristics. One class is called static biometrics, that I'm just giving you two examples. For example, facial characteristics. This is one good example of biometrics characteristics or features that can be used for authentication. For example, it means that it kind of it is inspired from human to human identification system. When we look at the face of people, of course we may look at different angles first of all. So the image or the photo that every time our eyes capture, they're not exactly the same, but we recognize that, okay, this is for example Dr. Patrugi, because his face has some features, distance between eyes, the shape of eyes, and stuff like that. We look at them. So researchers kind of got inspired from the human to human identification, and they said maybe we should use the same thing. So they come and define a set of characteristics for the face of the person and decide about the authentication based on that features. We will be talking about it a little bit more in details in one slide. The next parameter or the next biometric feature that can be used for authentication is called fingerprint. Of course, you know, fingerprints are believed to be unique for every person in the entire world, in the entire human population. And of course, they can be used for authentication purposes. Of course, we are seeking for something unique. Other static biometrics I want to I want to list for you: hand geometry, the geometry of hand, how your fingers are placed or positioned, the lengths of your fingers. That sometimes there might be some angles. Fingers might not be completely straight, uh, and stuff like that. So we identify features of the hand, including shape, length, and width, and stuff like that, and we use them for authentication. Retinal pattern, the pattern that we have in our retina might be used for authentication. Iris recognition or iris authentication, uh, which looks at the detailed characteristics of the uh, human iris. These are all examples of static biometrics. And the reason we say static is that they're supposed to be static. They're supposed not to change very much uh, when we capture them with respect to the first time. Of course, there is a first time that you enroll or you register in the system. It means that you, for example, your iris will be captured and will be turned into some features, and those features are being stored in the system. And the uh, times after that, their authentication and the patterns of iris captures are going to be compared against what has been stored in the very first time. So there might be some changes, of course, because we are all human and everything in our body may change over time, but they're not that frequent to change, or it's not expected to static parameters or static parameters to change too much. Your iris or your fingerprint, they're not supposed to change very kind of significantly. In contrast, we have dynamic biometrics, which they, by nature, they have or they bring huge amount of changes every time. For example, signature-based authentication. Of course, uh, when I write my name as signature or in my signature, whatever it is, my signature, I follow some patterns, and those patterns can be extracted and can be used as a unique style or as a unique uh, way of writing or handwriting for authentication purposes. And it's kind of clear for you that every time that I do my signature, it might be a little bit different. Of course, the patterns are still there, but in terms of uh, capturing that and in terms of turning into some binary numbers, for example, turning into images or whatever, there might be significant changes. Sometimes I sign my name, for example, let's say this way, and sometimes I do it this way. There might be a small or big. Sometimes, for example, I connect H and M. Sometimes I don't do that. So there are, when it comes to kind of digital data, this digital data has a significant kind of changes with respect to the previous one. So that pattern recognition that I talked about, it makes a uh, kind of bigger sense or happens more here. And also voice. The pattern that we have in our voice may change, and but 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 it still is enough for authentication purposes, but needs to be processed in a more complex way to be used for authentication. Okay, I will be giving you 3 examples of biometric-based authentication. We will be talking about iris recognition, retinal recognition, and yeah, and the third one is face recognition, or face authentication. Um, we will be talking about them, and I'll be giving you some more details about them, how they work, and what they exactly look for extracting that unique information. But before that, I'm gonna continue talking about biometric authentications in general. I'm gonna talk about stuff or definitions that apply to all biometric-based authentications. The first thing that falls in this general conversation is called accuracy or authentication accuracy. Uh, what it is, it says that you may, in biometric authentication, the system determines how closely the presented biometric characteristic matches the stored one. And this, of course, is the result of a pattern recognition task, and it gives us a number, and that number is not only 0 and 1, which is unlike the password and token-based authentication that they come say 0 or 1, true or false, yes or no. Here we say something between 0 to 1. We say, for example, these are very low close. 0 means that they are definitely two different things. And 1 means that, for example, they're exactly two same things. But we may end up getting a number like this, for example, 99.99, which means that these two patterns or these two biometric set, the presented one and the stored one, they're 99% similar. And I can authenticate you with respect to this 99 because, like I said, this is a pattern recognition. I barely get to the situation that I receive the pattern recognition of 100% similarity. I rely even on 99.99 or 99%, and I say that, okay, this is you. I let you in. So this is the, like I said, the big difference that we have for between the biometric authentication and other authentication that are based on password or token. So we have this concept of accuracy. How accurate can we do the authentication? How much we can get closer to one? Or we can also put it this way: how much am I confident when I say yes or no? When I let some people in or when I reject some individual, how confident I am, or how confident that authentication metric or authentication method is. So we have the accuracy. And like I said, the accuracy ranges between, let's say, 0 to 1. Maximum is 1, means that you are 100% confident your accuracy is 100%. And of course, you can increase the accuracy. For example, voice has a very low accuracy. In contrast, iris has a very high accuracy for authentication purposes, but um, their complexity and the cost they imply on the system might be different. So here we have this plot, which is a very nice plot. I really like. I like it very much. It gives us a trade-off between the accuracy versus cost of different biometric features or characteristics that we can use for authentication. We have voice, which has a very low accuracy and very low cost. We have hand recognition, relatively low accuracy, but high cost. Signature the same, face the same. We have retina here, emit accuracy, relatively high cost. And we have iris recognition or iris authentication based on iris detection, which has pretty high accuracy and of course impose high cost if you want to pick them, if you want to use them for authentication. So this is an important thing, that you want to do authentication based on biometric features. You need to know how much accurate you want to be and how much you want to spend. Okay, the general thing about general authentication model based on biometric, it's being shown here. It has two phases. The first phase or the first step is enrollment, like registration that we in that general slide that we talked about the authentication, we called it registration. Sometimes people call it registration, sometimes people call it enrollment. That's the same, but here is the time that the user presents the name and the password to the system, and also at the same time the system senses the biometric features or characteristics of the user. For example, they say, okay, put your eye here in front of this specific or particular camera, and uh, we collect information from your iris, or they say put your fingerprint on this specific device and we collect your fingerprints. That's the time that they collect biometric parameters or biometric information from us, from the user. And of course, we assign a username to that. Whose fingerprint is this? This is the fingerprint of a person named Ahmad Patuji, let's say. And also a password. Sometimes we also assign a password because for higher protection, we can, if we are, for example, not that confident, if we are in the confidence of range of, let's say 70%, means that we are the system, I mean, in the time of authentication, when it comes to authentication, we want to authenticate this person, but we are not that sure if this is Ahmad or not. So we ask him, okay, we somehow we are not sure, can you please enter your password as well? And that's it. Okay, after collecting this information, what the system will be doing is that, of course, these are some data read from some sensor. For example, you have, let's say, information coming from your fingerprint. That's a series of photos or images. Or if it's a voice authentication, you have collected the voice coming from a microphone. These are all signals, and if you look at the signals, they're very kind of, they look like a noise. They're something like this. For example, this might be the signal coming from a microphone when collects my signal. And it's not easy to compare this signal with the signal that next time I will be generating. Next time my signal will be something like this. And it's very difficult to say that these two belong to the same person. So what the system is doing is that they extract some features out of the data recorded from sensors, and then those features now are being stored as a set of numbers that can be used for comparison. That set of numbers that can be used or will be used for comparison is called a template. So out of my voice, which is something, a signal like this, jumping up and down very frequently, they extract some features, let's say 10 different numbers, and that 10 different numbers, for example, one might be the minimum versus maximum, or the energy of this signal, the frequency of this signal, mean value of the signal, stuff like this. These are features. Of course, there are, with respect to the application, there are different features, but we extract the features, and instead of storing the signal itself, the system stores the features or the template. And later on, when I come and for the second time or third time, I give the same voice, I repeat saying the same thing, features again will be extracted, and the features will be going to compare against the template. Okay, so here is the enrollment process in this chart. You see the user come, for example, put his finger on the fingerprint reading camera or fingerprint reading sensor. Sensor data will be collected, something like this, and then feature will be extracted. Feature will be stored in the database of the authentication server, plus the PIN, plus the username and password. So this is the enrollment process. And later, the template can be used for two purposes, depending on the application. The template can be used for verification or for identification. Verification here means authentication, means that we want to authenticate the person, and that I'll be talking about. Okay, in the verification, which is kind of similar to the case that the user wants to log in to the system using a password or a memory card. The user, this is what happens for the verification. The user comes, put his finger here. For example, let's assume that it is a fingerprint biometric. Puts his or her finger here, and again the biometric sensors collects data. Features will be extracted. Features will be using the PIN or using the username and password, sorry, using the username or using the PIN, the record or the template of that person will be extracted from the database. And these two set of features, the template versus the recently extracted features, are going to be compared against each other. And then we come with the decision, true or false. We grant access to this person or we reject this person. So this is what happened. User enters the PIN and the features of the kind of new collected data will be extracted and will be compared against the template stored in the database. So this is for verification, or let's say authentication. For identification, though, it's different. Identification means that we just want to say who is this. We don't want to grant some access to them. So it's a little bit less sensitive than authentication, because here we are making a decision and we want to let some person in or we want to reject that person. But here in the identification, we just want to identify that, and we just want to say that, okay, this voice is Ahmad's voice, or this voice is Bob's voice. That's what we want to do. We don't want to grant any access to them. We want to detect who is this or identify who is this. Again, the individual comes, the biometrics data should be read. The biometric data, for example, here in our example, the fingerprints will be read using the sensor. Features are going to be extracted, and the features are going to be compared with in the database, or we search in the database to see if we can find that. And then the decision is this: we say that, yeah, we identified this user is someone we know, or we couldn't identify this person. This is an unidentified or a new person or a new user. So this is the verification that, like I said, verification here is synonym to authentication to us. So verification here is synonym to authentication for us. And identification is something that we don't have it in token-based and in password-based authentication. Look, this is something unique about biometric authentication, that they give us a side product, or they give us a side mechanism called identification that we don't have it in password-based. In password-based, if I come and if I enter my password, you exactly know who I am. I am Ahmed, and the password is correct or not, because I personally should give you also the username. But in identification, you can say, who is this? And like I said, this is a functionality that we don't have it in user-based authentication or token-based authentication, but we have it in biometric-based authentication. Okay, now let's talk about 3 examples of biometric authentication. The first one I'm going to talk about is iris scan or iris recognition, that based on that recognition we do authentication. And the way it works, first of all, where's the iris? The iris is the colored part of the eye, colored portion of everyone's eye, which is called iris. And that is believed to have a unique pattern for every person. The way they work, they record a small, short video, and that short video will be used to extract some features. The iris scan or iris video are believed to be very accurate for identification and for authentication. And the good thing is, iris scan can be used as a continuous monitoring or continuous authentication. It means that as long as you are here, this system works. We don't wanna allow you at the start of the session and then you are good to continue. No, we always look at your iris. Your iris, for example, here is a computer that has some very sensitive information or accesses. So the camera is on, and as long as you, the legit person, you are sitting in front of this computer, it works. The moment you leave the chair or you leave your desk, the system will be locked. So we can offer some continuous monitoring or continuous authentication using iris recognition, and it's very well developed and accessed. And the response time is something between 1 to 2 seconds. So it is not real time. You collect the information, you record a video for, let's say, 2 seconds, and then it takes another 1 2 seconds for you to process that and decide. So we are always, let's say, 3 to 4 seconds behind the user, which is not that bad. The second example is retina based authentication. And the retina is kind of basically in the retina recognition or retina scan, they also they look at the blood vessel patterns in the rear portion of the eyeball. This is called retina. The pattern of blood vessels that we have in the back portion of our eye, this is called retina, and that pattern is believed to be very accurate or very unique and can be used for authentication. Of course, some changes may happen into the retina uh, patterns because of some health situation or some physical condition. For example, if I'm diabetes, something may happen, or pregnancy or heart attacks or stuff like that. They may induce some changes in the retina of my eye, but that's not very severe or very often, very kind of frequent. So that's why people uh, kind of rely on retina based authentication. And the response time is something between 4 to 7 seconds. And the last example that I'm going to give you is facial recognition or authentication based on face recognition. The way it works is this: they capture a video from the kind of individual's face, again, a short video. And of course, at that time, which is the time of enrollment or registration, they ask the individual to hold their head in a specific direction with a specific angle. Don't change it too much. And uh, out of that video, many parameters will be kind of calculated. For example, the shape of eyes, the shape of chin, jaw, and the length of or the width of the, for example, nose. And a graph like this will be extracted out of the person's face. And this graph, which is basically the features or the template, will be stored. And anytime next that you come, again, the same video will be recorded, the same graph will be extracted, and then the two graphs are going to be compared against each other. Of course, it is not that accurate because you may move your head, you may kind of look at the camera with different angles, a little bit different angles that affect, for example, let's say if you even turn your head 5 degrees toward left or right, the distance between two eyes will be affected. So it is not as accurate as iris or retina based authentication, but it is still good. And again, can be used for continuous authentication, which means that we can make sure that this is the right person using the system for the whole period of the session, not only at the very start time. Okay, now let's talk about the comparison. We here mentioned to the fact that uh, that for biometric authentication, um, a set of features will be extracted and will be stored as a template. And then anytime later you want to get into the system, again, the feature will be extracted and the two set of features or the template and the new set of features will be compared against each other. Of course, this comparison, like I said, we shouldn't expect to receive 0 or 1, a result of 0 or 1, 100% match, 0% match. No, when we compare them, the result can be something between 0 and 1. 100% similarity, 0% similarity, and of course, we can get something here, 80% similarity. In general, in the biometric-based authentication, they say the output of the comparison, which is being, let's say, a single metric, a single kind of comparison value, that value that we called it here S, that value can be seen as a random variable. What is random variable? A random variable, for those of you that you haven't taken any probabilistic course, a random variable is a number, is a kind of number that takes or gets random values, and it may have different probabilities between 0 to 1. It randomly picks different things. Of course, some numbers they have a higher probability to happen, and some of them they have less probability to happen. So the way it works is that they say, okay, this is our S, this is our random variable, the similarity, and this is the probability distribution function. Every time that the person comes, the matching value might be, for example, something, let's say 0.8, 0.9, or whatever. And of course, most of the time that this person comes, we get something around the mean. Here is the mean or the average. Most of the time, we are close to mean somewhere here. And it's very kind of less probable that we get something here or something here. So they define a threshold. They define a threshold and they put the threshold somewhere here. And they say, okay, if you are in the right side of this threshold, it means that you are good to go. If you are in the left side of this threshold, we cannot trust. It means that something here in this part that I explained, the output of the comparison might be something between 0 and 1, and we define something, let's say we say anything about 75%, we let it in. Anything below that, we reject it. So if you do that, two things will happen. We will have false match rate and false non-match rate. False match rate is the rate of erroneously accepting rate of the times that we erroneously accepted someone which is not authentic. This is called false match. And of course, we want to keep it very low. We want to keep it, for example, let's say below 1% or very close to 0%. So this is the false match. This, let me clear the okay. This area, this lighter gray, is false match. Why? Because this is a profile of a non-legit person. This is a profile of a person who is not enrolled here. And this is a profile of a genuine or a legit person. So this kind of lighter gray, lighter shaded area belongs to a person who is not legit, and we should, or the system should, reject them. But the system, because the value of their comparison is about this threshold, the system doesn't understand and let them in and grants them the services. So this person will be accessing the services or functionalities that he or she is not supposed to. So we call them false match rate. We also have false non-match rate, which is this kind of darker shade, and is the case that a proper or a genuine user comes, or an authentic user comes, and we mistakenly reject them. This one also we want to keep it low, let's say below 5%, but of course it's clear for you that the false match rate is more important, because of course we don't want to, you may come, this may happen to you. You want to enter to a building with your fingerprint. You put it for the first time, it doesn't let you. You put it for the second time, it lets you. You are authentic, you are legit, you have the permission to use that room, but for the first time you fall in this category, false non-match rate. So this is not that important, and it ends up forcing the user to reapply or re-enter the biometric information. But this is very important, very sensitive, very severe. We don't want to let anyone who is not legit to access to our resources. So this is how the processing works. Okay, we are done with biometric features and biometric authentication. We have covered almost everything. So please use the word characteristics for the attendance code of this video. Use characteristic the way it is written here with uppercase C, and then everything else is lowercase. The only remaining slide about this lecture, or this part of this lecture, because we are also going to talk about access control, it is remote authentication. What is remote authentication? Of course, when it comes to authentication over the network, we would be vulnerable to many different types of attacks, eavesdropping, capturing a password, replay, and stuff like that. And for that, authentication over the network is sometimes it is referred to as remote user authentication, and some people have shown kind of a more level of sensitivity to that and made it more complicated, or more kind of robust against attacks. Here is one example of or a general case of remote user authentication, at which a user or a client is going to access a host over the net. It works like this: user sends the, and again, this is a general model. Details might be different in different models, but user sends the username, and then the host or the authentication server returns three things. One, a random number R, which is called the nonce, and a hash function, and a different function. So it returns a random number, it determines a hash function, and a separate function that we call it f. The user is supposed to calculate f of its f of this value R, this random number or the nonce, and it's his password. The user doesn't kind of send the password. It uses the hash of his password. So let's say h of p, or capital H of p, doesn't matter. So it calculates that function that takes R as a one parameter, and hash of the user's password as a second parameter, and send it to the um, authentication server or to the host. And now the host calculates the same thing. The host has R, because R was generated by the host or by authentication server. So the host does have the R. So it takes R. The host also at the registration phase generated a table like this: username and the hash of password of the username. So this is a password file. We've talked about this for different users. So the host goes and extract the hash of the password of the user from its password file and put it here as a second parameter of this function f. The function f is also defined by the host, so the host knows the function. applies the same function on the R and the hash of the password, and compares whatever it generates, whatever host calculates, with respect to what came uh, from the client. And if these two matches, it means that this is a legit user, this is an authentic user, and the grant will be kind of the permission will be granted. Otherwise, the user or the individual will be rejected. Which is basically kind of very similar to what we have covered. Basically, they call it, they combined, what you see here is a combination of password-based authentication plus challenge and response authentication that we have seen in token-based authentication. It's a mixture of both for increasing the security. And here are the list of kind of vulnerabilities or attacks that might be applied against authentication. We have eavesdropping, host attack. We've talked about most of them: replay attack, client attack, Trojan horse, and denial of service. That I'm not going to go through the details of attacks because that might take even itself a couple of weeks. So I think that should be enough for today and for this lecture, for this part of this lecture. In the second part of this lecture, we will be talking about access control, and that second part is going to take a week. And then after that, we'll be talking about probably operating systems security issues. I want to use this opportunity and kind of encourage you to work on your research projects. You are supposed to read the papers, talk to your friends, and come up with the video, record a video that which is your presentation. The rubric on Blackboard gives you first the rubric, and then at the end of that file, I'll give you the expectation from the recording, what the recording should be, and how, for example, how many, what's the time length that you should record the video, and how you upload it on Blackboard. Stuff like that are also mentioned in the rubric. So please look at the rubric and let me know if you have any question about the research presentation. This is the last month of the class, assuming that in the last week, in the May, we will be reviewing the course, and I'm not gonna give a new stuff to you on that very last week. So this is basically can be seen as a last month of the class. So this is a time that you should put on the research, and a good portion of your kind of growth, your grade also depends on the research. So please look at the rubrics and let me know if you have any question about what you are expected to do in the research activity. Thank you again, all of you, for making this video, watching this video, and have a good rest of the day.